Hello, folks. I am Ken Briodagh, Editorial Director for IoT for All, and your host for today's webinar, Beat the Odds, How Agile IoT Can Get You Past the Pilot, or the Case for Agile IoT Development. And thank you all so much for joining us. We're really excited about this presentation with Ben Wald. But before we get to that, I just want to do a few housekeeping notes for your edification. First up, yes, this presentation will be available in an archived format after we're finished. So you'll be able to rewatch or share with colleagues. So you'll be able to view that on the IoT for All page, and you'll be getting an email with those instructions after we're finished. Also, please feel free to submit any questions you have for Ben throughout the presentation. There's a Q&A button down in your dashboard near the bottom. Go ahead and click on that, type your question in, and we will take a look at them as they come in or where appropriate throughout the presentation. So we're not saving them all for the end, but we're going to try and get to them as we progress through. I think housekeeping wise, that is all we have for today. So you may not be aware of this, or maybe more likely you are because you're here with us today, but the IoT has a huge potential for development, but it also kind of has been having a big problem. Gartner has estimated that 3/4 of IoT projects fail before getting out of the pilot phase. And addressing that challenge is really a huge and complex problem, unless you simplify it with something perhaps a little bit like Agile IoT. Our speaker today, Ben Wald, founder and head of client strategy at Very, is going to walk you through the Agile IoT development process and give you an idea of how a strategy, when implemented in this way, might help you get past that pilot purgatory. Ben, I'm gonna hand it over to you and let you take the field here.
All right, Ken, thank you so much. Excited to be here, excited to talk about this. So let's dive right into it. There's 3 sections of the presentation today. First one is talking about the top reasons why IoT projects fail. The second one is we're going to look at 2 different methodologies that we see, Waterfall versus Agile. And then we're going to get really tactical. And we're going to talk about 10 steps that we typically go through in all of our IoT projects. So just to level set, as you were talking about, Ken, IoT has a huge potential economic impact. That's why we're all here today. That's why, as a company with 100 engineers, we've focused on IoT. The trend lines are extremely compelling. But as you mentioned, 75% of all IoT projects fail. And just to also level set on where my perspective comes from. So I founded Very about 10 years ago. We've delivered on hundreds of projects. And one of the things that we have the benefit of as hired guns or consultants that get dropped into situations is we get to see a lot. We have a lot of repetition, and we get to see then patterns of, what are the things that you can do to increase the odds and probability that you are successful, and what are the patterns that are kind of lead in a low probability of success direction. Lastly, is that this presentation in various forms, typically has like really high quality stock footage. I decided that 2020 was a pretty heavy year for everybody, and that we needed to replace the stock footage with something a little bit better. So you'll see a theme through this presentation is Legos. And without further ado, let's get this thing going. So let's start again by talking about the top reasons why, from our perspective, IoT projects fail. And some of those really common reasons are silos, staying in your sandbox, the real world is messy, skimping on the upfront validation work, and choosing a methodology of waterfall. So let me go through those in a little bit more depth. Part of the reason why there's such a high failure rate in IoT projects is because it is a multidisciplinary venture. It requires people from different fields working together and what would typically be very separate work streams coming together, right? So building a software platform, you're working with software engineers, the software engineering team, then can break down between cloud and application and API and all of these different disciplines within software, but it's a part of one software team. When we're talking about IoT, we need to engage mechanical engineers, electrical engineers, firmware engineers, software engineers, cloud architects. And when you start to tackle something like security, the risk vectors are everywhere. And so it is inherently a much more complex project. All of them are, no matter how simple, the device or sensor that you're putting out in the field is going to be. So why do they fail? Number one is that people stick to their silos. And really it just comes to a communication issue, and that when somebody is staying in their silo, they're not passing the ball well enough between these different phases. Number two is similar, but it's staying someone is staying in their sandbox, which means that they're putting blinders on, and they're really focused on the mobile application. They're really focused on the hardware engineering, or something that they just get laser focused. Laser focus is not a bad thing. But when you have blinders on, there are so many different pieces that need to be choreographed. It can really be challenging. Number three, the real world is messy. We see this all the time. You have the best plans, the best intentions in the world, and you put this device out in the field, and it's used in ways that you couldn't even conceive of. Humans are treating your device a lot less delicately than you had imagined. The conditions, no matter how good of planning you did with, type of environmental conditions, those can change and be challenging and present all kinds of issues. The real world is messy. Number four is skimping on the upfront validation work, and we're going to talk about that today and the tools and steps that we go through. But what this really comes down to is jumping in too quickly before defining ROI. And when we talk about defining ROI, the company needs to make sure either is this being developed for cost savings or new revenue opportunities or some type of efficiency. If you can assign or project dollar figures for what that return could be, it can help you dial in what size of an investment you should make. And sometimes we see a mismatch where either a company or a client is over-investing or under-investing because they haven't taken the planning all the way through. Last one is waterfall. Waterfall in software sometimes can work. From our experience in working over hundreds of different projects and clients, and with projects for freshly minted startups all the way through large Fortune 1000 clients, waterfall does not work when it comes to IoT. All right, so the focus of this presentation is that from our perspective, all of these problems can be traced back to one thing and can frankly be fixed by one thing, and that's the choosing the right development approach, or they can be traced back to the wrong development approach. So we're going to do a little bit of a face-off here. We're going to talk about the differences, the pros and cons of waterfall versus agile. And agile is not perfect, and agile is not like this perfect construct where only amazing things happen. It's challenging. There's some cons. The other question that I get isn't, aren't you just kind of relabeling, and isn't agile just kind of waterfall, but with some different words? And I'm going to do my best to call out the differences, the things that make them from a process perspective very different. So we're going to do a little bit of a face-off now. So when I say waterfall, what I mean is that a project goes through these different steps: requirements gathering up front. We go into a design phase. We then go from, wireframes to lo-fi to high fidelity prototypes. We then, can do user testing with the prototypes. We then finish those designs. We say these designs are done, and now we send them into development. Development occurs. And then when we're finished with everything, we say, okay, now we're entering a testing and QA phase. When the QA phase is done, everything works in theory. Then we deploy, and then boom, the product is live. But really that just means maintenance. Now we go into maintenance mode and cleaning up technical debt and, fixing and handling customer service and customer success. This is what I mean when I say Waterfall is a project that happens in this sequence. From our experience, when we've had to jump into things that are either we're looking at a retrospective of a process that took place, or from our experience, the upfront requirements gathering and documentation phase is relying on previous experiences. During the design, the development, and the testing phase, very little learning occurs. You're not talking to people kind of outside of this development workflow. The most learning happens when you finally deploy this into the real world and you have real customer feedback, you have real load coming through the system. And then by the time that you get to maintenance mode, you're treading water and you're fighting to survive. Let's talk about the pros. The pros are that typically the end goal is defined very early. And that like level of concrete definition for the end goal is not something that you see in Agile. So this is kind of a pro for Waterfall. Second is the process is easy to understand. There's kind of stage ends, new stage begins, information is transferred. That leads to the next point, which is there is good transfer of information between those steps. Typically, there's a big focus on documentation as you reach the end of the design or the development phase. And so, that can help. Let's talk about the cons. Major changes really require going back to the beginning and unwinding. Working software is produced very late in the development process. There's high risk and high uncertainty when you go to launch because it maybe hasn't seen real customer traction before that. And again, to wrap it up, you can't adjust midstream without causing huge amounts of damage. So let's flip the script here. Let's talk about Agile. This is a workflow of XP. Agile has a lot of different names and you can kind of play buzzword bingo with Agile. You've got, Kanban, you can use Scrum, you can, use all these feature-driven development, XP, so on and so forth. When we are talking about Agile, the most important thing is that you are going through the release planning, an iteration, acceptance test, and a feature release many, many, many times. And so when we're building projects, we're usually looking at either a 1 week or 2 week iteration. And so every 1 or 2 weeks, we are launching to production or pushing code, into whatever environment we have set up for that. So a really simple way to distill this is, kind of this chart that we have in the upper right-hand corner. You learn, you build, you measure, you learn, you build, you measure. And idea turns into code, gets launched, turns into data that we collect. And so let's talk about the pros. The pros of Agile are that it's built to adapt for change. When you have tightly focused iterations, you can adjust to changing business requirements. You can adjust to learning things out in the field, and you can change without having to unwind work. Working software and hardware is produced extremely early. There's a big emphasis on putting this in customers' hands or a beta group into their hands very, very early as possible. High emphasis on user testing, real user testing, not hypothetical. We want to put these devices out in the field, even if there's just 5 of them, and have people bang on them. Breaking down silos, and again, to sum it up, scope adjustments can be made very easily. All right, Agile is not perfect. Agile is incredibly difficult to do well. It requires excellent communication skills. The end deliverable is less certain at first, and unless you're careful, you can get trapped into an endless cycle of iterations. And what we mean by that is that a product is never going to be finished. You're always going to have in theory, an endless amount of iterations, and it can be hard to kind of drop a flag on, okay, we're going to kick off our marketing initiative. We're going to say that this is launchable. We're going to put this in customers' hands. All right. And the struggle is real. It's not black and white. But from our perspective, Agile is the clear choice when developing IoT projects because of all the reasons that we covered. So there's a little natural breakpoint here before we get into some of the tactics. So far, are there any questions?
We actually do have a few questions here that I'd love to get into.
I see.
And the first one comes in here from our audience. So I'm going to give them first go, even though I have some too. So you're welcome, audience. What do you recommend, or what would you think of as the ideal duration for a sprint in IoT?
Great question. There, we have a couple different versions of a sprint, and the first one that I'll cover is kind of like an upfront sprint, and we're going to get into the details. But typically, before we kick off what we call a build, or before we start writing code, we do a technical design sprint, and that technical design sprint for a really complex IoT project is maybe 5 weeks. For something simpler, can maybe be 2 weeks. And in a 2-week sprint, a lot of that is just going to, like, the output of that sprint is going to be documentation. It's going to be like, here's the cloud architecture, here's the data architecture that we want to enable. If we need to use data science or machine learning, like, here's a little bit of recommendation on how it could work. Here is like a, as far as you get is maybe like, here's a quick bomb that, we're going to test out later, but like, here's the bomb, here's the cost. Generally, this is what it looks like. If we're doing the 5-week version, we're focused on doing a working prototype at that point. And, or if it's something like web-based, it's a clickable prototype. So anyways, that's a little bit of the duration. In terms of cadence moving forward, our world is 1 to 2 week sprints. And those are, iterations where we're shipping code, or, we have like milestones that are based on those different increments of time.
So with that being said, in the Agile process, you talked about getting to sort of the launching a product fast and
Yep.
and trying stuff out fast. Doesn't that sort of risk early release or bad PR or something just hitting the public before it is working the way you want it to work?
Great question. So, and one of the useful frameworks that I think we lean on is the difference between an MVP and an MMP. Not sure if you are familiar with those acronyms. MVP being minimum viable product, MMP being minimum marketable product. And so when we are doing and launching early, we are initially we structured as typically employee field trials, employee pristine field trials, customer field trials, customer pristine field trials, right? And so step 1, you're putting this in the hands of your employees. Things go wrong. It's not pretty. It's a 3D printed enclosure. Nobody cares. Everybody gets the drill. You then want to take it to your employees to do what we would call a pristine field trial, where like you might have a manufacturing run on the enclosure, so it looks a little bit more polished. Then you're releasing it to customers, so on and so forth. And the goal is that you really don't start marketing this. So there's an external communication piece until you've got your MMP, minimum marketable product, which has or necessitates a different level of polish. So we're realistic about like not saying that this thing is the best thing in the world and it's done and it's polished and it's ready. But we want to, you want to frame that external communication well. The last thing that I'll say is that if you do this well, and I think, for example, Tesla does this well. I get a firmware, update every couple weeks, right? And so they have like made it very clear that this product is not done and that you should expect the product to improve. And you should expect, like, if you find a bug or if something doesn't work, hopefully it's going to be fixed in the next firmware update, or you just go onto the mobile app and, set up a ticket. But setting that expectation up front with your customers, with the market, I think can pay dividends down the road.
I think you're probably right. And I think that consumers are getting much, much more used to that sort of thing now, as with software, especially and IoT type products. Folks out there listening, keep sending them into the Q&A. Our Q&A is starting to heat up. We got a lot of questions coming in. I think we've got time for one more in this segment before we move on. So God, I got a couple of good ones here. I'm trying to pick which one I like better. You can see them too, Ben. If you see one you'd rather do, let me know. But I kind of like the one from Eric that came in there.
Yeah.
All right. So, are there any strategies that you've used to convince a customer to move to Agile or versus Waterfall or from Waterfall? Many companies doing this digital transformation process are still working on older styles of thinking for development. So, have you made that helped customers move through that transition?
Definitely. And we encounter this every time. And a lot of, I would say the bulk of our clients are mid-market companies that are going through some type of tech transformation, typically led by maybe like a Bain or McKinsey or Accenture, who are then bringing Very in as the execution partner. And so most of the time, especially in these mid-market or enterprise companies, there's a people are comfortable with the top-down methodology, right? And before I answer this, I want to say that Agile is not an excuse not to do upfront planning, right? And so I want to make that very clear that, and this is probably where like our specific execution of Agile blurs the lines a little bit, because we do a lot of upfront planning. And I'm going to talk about that here in a second, which is like how far to take that and how much to invest, because at some point you hit too many assumptions that, time is being wasted if you go down too much further. But anyways, the question is, what strategies have we used in the past? I want to return to this later once I go through the 10 steps. But the first thing that comes to my mind is that there's, if everybody's familiar with like the challenger sale or the challenger sales strategy, is pretty much based on like asking really tough questions. And I think what we find is that when we're dropped into a situation, if you can ask really tough questions, you can help the stakeholders realize that like their best vision of something that is going to get launched 8 months from now has a lot of holes. and if you can kind of like pry at that, it is not intended to create uncertainty in the project, but it is, you can use that to advantage Agile to say, look, we know those exist. Let's work to validate them. But in the meantime, we don't have to not make any progress. I think the second thing that I would say is that in most of the cases that we're being brought in, the time to market is important. And so what we say and have data to prove is that going through Agile is quicker than Waterfall. You will get to market quicker. And launching something into the market, I think, for everybody that's investing $500,000, $1 million, $5 million, like they're trying to seize an opportunity. And so I think that is kind of the other piece where, like, from our perspective, we have multi-year engagements, but we don't have any projects that take multiple years to build. We're hitting the ground running. And because of the way that we coordinate work streams, we're launching an IoT device into the field in 7 months, or something in that range. Again, it depends, but we're not talking about like, let's wait 2 years for this thing to get built and to be perfectly tested. Let's get out in the field, let's get market research, so on and so forth. So those are the two things that come to mind, but we can return to it later.
I think you probably had everyone at faster time to market. I mean, we're done here, right? I think
probably that's the most important one. Yeah.
But why don't you keep going? I know I've got more questions here, and I have to warn you, some of them are hard questions, so I'm coming at you. But let's keep moving through here. I want folks to get all the way through.
I love it, and hopefully people aren't feeling like the logo or the Lego that's dangling right now. So we'll. My goal in this is to talk about specific tools and steps to kind of turn this from like hypothetical Agile is great belief system to like, here's how to take the steps to do it right. So let's rock and roll. Let's talk about the 10 key steps to making this happen. And the basics, again, baselining here, this is not just relabeling Waterfall. The focus is constantly prototyping, constantly shipping, and frankly, unlike Waterfall, blurred lines between these stages are a good thing, not a bad thing. Again, on level setting, this is the diagram that we use in every project when we start to talk about an MVP. And this becomes like one of the favorite diagrams. And there's this like narrative that emerges where people, we and the client start talking about, okay, what's our skateboard going to be? What's our scooter going to be? And the important thing is on the top, how not to build an MVP is you start with a tire, then you add a chassis, but the chassis can't go anywhere. Then you kind of like mount a body and the car still can't go anywhere. You still can't actually drive this anywhere. And then we're hoping at the very end that it all comes together perfectly and it's beautiful and it drives very fast. The bottom approach is, okay, what's a skateboard? Okay, now how can we give that skateboard, some more steering capabilities, turn it into a scooter? Okay, let's try to make it go faster. How can we make this go faster, more performant, so on and so forth? You get the gist of where we're going. But this, like I said, this chart ends up becoming, kind of this like framework that we go back to when we talk about it. We're like, is that our bike or is that our motorcycle? Is that our skateboard or is that our scooter? So this is a favorite. And I think lastly is that this is a chart of what's it's a framework called adaptive planning. And when we're starting to talk about, okay, how far into the future is it a bad investment to plan for? These are kind of the thresholds that we look at and the level of focus that we're looking at when we're doing like long-term release planning. All right, so what are the 10 steps of Agile? Start with validation and constraints. Build a product development roadmap. Bang out the prerequisites. Imitation, 2 parts of simulation. There's a microfacturing run. There's a manufacturing run. There's a real manufacturing run. I'll get into the nuances there. You've got your go-to-market manufacturing run and then emulation with digital twin. That's what we're going to be covering here. So step 1, validations and constraints. The goal here is that we want to steer into the riskiest assumptions up front. And what we want to do is really kind of start painting on a blank canvas. You're ready to move on when you know what your ROI is going to be. You've landed that somewhere. And I'm going to step through a couple of the tools that we use. So number 1 on the left is we're looking at proto-personas, which can be a really helpful framework. Sometimes you dive into an IoT project and you take a step back and you're like, what are the use cases what are the real use cases that we're building for? So proto-personas is an exercise that we go through. We've got a little bit of an image of a lean canvas can be a great tool. A/B and user testing, really upfront user testing that we can do, where even with like wireframes and no design, you can do preference testing and so on and so forth. The last one in the bottom right-hand corner is customer interviews, talking to real customers. So getting on the same page with them, having real conversations, all of that can typically lead into building some type of an equation to determine ROI. Step number 2 is we want to build a product development roadmap. And we're going to build this from the ground up. You're ready to move on when you have a well-articulated product development roadmap, and I'm going to show some examples of what that looks like. So number 1 is we use a framework called job stories. When blank, which is the situation I want to, motivation, so I can expected outcome. When we are writing features and writing cards, we are starting with job stories. Number 2 is that we're building out all of the key workflows. And key workflows are important because one of the things that we do is we focus on outlining what the SAD paths are. SAD path, as you can see, is a login error. This is like a super simple, this is the workflow map for a login process, right? So like, forget about the entire architecture of the main application. This is just the login process. And we want to make sure like, okay, if there's a login error, how are we doing forgotten password? How are we sending that token? And how are we going to kind of gracefully handle this? And I guarantee you that if you go through and do workflow mapping like this and think through all of your SAD paths, you will end up with a much better IoT product. And frankly, I think that's typically the difference between good and great. And sometimes when we're doing research for projects, we'll go and we'll look at the App Store reviews. It's one of our favorite research things to do. Look at their competitors, look at App Store reviews. And the things that get apps And so this is more consumer versus industrial. But the thing that gets apps 1 stars is when people like, are having trouble pairing their device and the app is not helping them troubleshoot. And they're like, screw this, I'm just going to delete the app. I'm done, return the product, 1-star review. And so one of the big differences, because IoT is hard, pairing devices is hard. I have a fan behind me that, I control with my mobile phone. It's hard to do. But the way that you are thinking through and gracefully handling sad paths is a critical jump that I think, is like one of the keys to success. When we are story pointing, we use a Fibonacci scale of story pointing. And so we're giving cards or features 1, 2, 3, 5, 8, 13, 20, and never really 40. But and that is a level and estimate of complexity. Typically, one story point relates to one ideal uninterrupted day of engineering, although it's most importantly a measure of complexity. And if you are looking at a board and you've got all 8 story point features, that's a signal that you need to break things down into much smaller bite-sized pieces. We use Jira a lot these days, and this is a little bit of what a backlog looks like when it all gets put together. And so, you're starting to stack cards, you're starting to identify sprints. Jira is a great road mapping tool that we use. We've used Pivotal Tracker as well, and it's about how you use the tool and how you organize around it. These are some shots of exports within Jira where you can actually start looking at a roadmap where you're starting to tie in and look at dependencies. You're looking at a burn up of story points, and then also cycle times. And one of the things that we look at to judge whether a project is healthy or not is cycle times. So this is kind of a really important thing to look at, is how long are things getting stuck in review? How long are things getting stuck in, in progress, so on and so forth. So all that goes into building a well-articulated roadmap. Now you're ready to go. So this is where the build really starts. And the step 1 is going to be from a hardware and software perspective. Let's hammer out the basics. Let's get a dev board in our hands. Let's do some hand soldering. Let's print something with a Volterra. And when you're ready to move on, when you can plug it in and it works. The next step here we call imitation. And so the context is that the foundation is set, and now it's time to make this device do its business, but it's possible or even probable that none of the components that you're using will be final. So from a hardware perspective, this is where you want to get this device to reliably establish a network connection, reach out, see if a firmware update is available, start doing its business, start reading some type of data, so on and so forth. From a software perspective, this is where we want to have our OTA firmware update process in place. We've got a pub sub configured. Devices can subscribe to a topic. They can listen for messages, publish messages. The goal, again, is to get something working and start to harden the basics. We're ready to move on when it can reliably function. So you can turn it on and reliably it will start to work. The next step is simulation. And the context is which components come first or last is really dependent on the project, but you're starting to cement some of the decisions and starting to work with real components. From a hardware perspective, you're starting to swap out temporary standing components for ones that might be final. From a software perspective, for example, the device is working, it's sending data to the cloud, but it's not necessarily working with a specified or a specific API integration. At this stage, we might be using nerves to orchestrate, to provide end-to-end encryption, to provide some of that over-the-air firmware management. And for us, it takes about a week to set up. On this stage, we also might want to start getting comfortable with the dashboards that we're going to need to send this data to. The goal is that we build a device that can receive, an administrative command with some real components. This device can subscribe to an AWS topic, for example, simple commands, turning it on and off remotely, especially if this device can't power cycle on its own. So this device can do its business on reboot, nothing fancy. And depending on the platforms and frameworks you start with, Like, for example, nerves, you get a tremendous amount right out the gate. And so this is where you're going to start to realize some of the value from starting with a framework. You ready to move on? When you have a good idea about where the refinements are going to be and what those final components should look like. Simulation part 2. So again, there's two parts of simulation. The context here is that every engineer has one of these on their desks, and everyone's itching for the first manufacturing run. At this point, the device has hopefully all of its final components. From a hardware perspective, the device is working on a dev board. Maybe you've got the final CPU architecture, the final Wi-Fi chip, the final sensors. From a software perspective, you should be starting to bring the bulk of the software development home. We're at this point then starting to turn to the final API integration, the final pieces. And the goal of simulation part 2 is that this device is using a real CPU architecture paired with final cord on a dev board. The enclosure isn't there. It's not polished up. It's not perfect, but Frankenstein is alive. So the next thing that we're going to do is we do what we call a microfacturing run. Context: everybody's been jamming. We're ready to commit. Feels good, looks good. And now we want to get 5 of these built and sent to the devs. These are going to be hand soldered. We're going to have 3D printed enclosures. You know, the boards may have way too many ports. And these will be thrown away. These will not maybe kept as mementos, but these will all be thrown away. From a hardware perspective, here's when you want to start considering your final enclosure and material decisions. We want to finalize the industrial design and finalize the kind of the human factors. You know, you've had a printout up to this point of like a really awesome 3D rendering. You know, you spent way too much time on the lighting effects. You know, you've produced some exploded views for your investor presentations or your stakeholder presentation that look really awesome, you know, so that everybody can see where the screw holes and screws line up. But now we want to make sure that we can start finalizing these specs. This is where we would maybe send out for a finite element analysis. We would do environmental testing. We would run some models for testing for like high stress areas in the mechanical designs. And we'd be looking at recommendations for methods to alleviate, I don't know, some of those high stress points on the enclosure. So what's the goal? The goal is we want to put a hand soldered 3D printed device into all of our engineers' hands, and we're ready to move on when we feel like we're ready to give these to some beta customers. And again, the key here is like, we want to surface if there is anything fundamentally wrong. All right, so now we get to the first manufacturing run. And when we think about this, we're thinking about 100 units, let's say. So the context is you want to feel relatively confident with your decisions up to this point, and you're ready to get a true pilot group engaged. From a hardware perspective, there's a custom board. You've removed everything unnecessary and ancillary. It's important to tighten things up, especially to reduce like the physical vulnerabilities from a security standpoint. You want to have the final components here. You've got maybe doing your initial take at a final-ish enclosure, and you're doing a run that's injection molded versus 3D printed. From a software perspective, you're starting to hit load. You're really leveraging the API now for everything, and you're starting to optimize infrastructure as needed. From a UX perspective, you're starting to really consider the implications of using this. Both the physical device and the app screens or the web pages where you're posting data to, and how those devices are connecting to each other, how they're interacting, and so on and so forth. From a testing perspective, you know, we're going to start doing FCC pre-certification and UL testing. At the end of the day, the goal is we are going to get a pilot group engaged, and we're going to finalize the board layout. This, again, we've found that this has implications on the enclosures. We're going to listen to the drivers of change that are now like customer related versus engineering. And we want to get ahead in this stage of our mass manufacturing run, our hangups that may happen. You know, so for example, have we figured out and accounted for the time to source all of the raw materials? Have we taken a crack at our final bill of materials? This is going to allow us to do some early checks with our manufacturing partners. making sure that they can handle the types of volumes that we need them to. And like, are we double and triple checking all the standards and regulations that we're going to need to comply with? When are you ready to move on? You've received feedback from customers. You're ready to make the needed and necessary tweaks. And you are not freaking out at the thought of doing a much larger manufacturing run, which is typically going to be, some real cash that you're going to have to outlay here. So at this point, when you're doing a 1,000-piece run, the only changes are going to come from real world feedback. In this stage, we're going to be running field testing, usability testing, training and onboarding. Maybe we're starting to field some early like customer support and service issues. We're starting to figure out like, what is customer success going to look like from the organization's perspective, where we need to support customers and training. From a hardware perspective, this is where we're going to maybe start to figure out and find some longevity issues. Maybe some of the glue is wearing out. The real impact of temperature and environmental effects. This is where we want to start getting this data. The goal is that we perform initial user testing, training, and onboarding. At the end of the day, you can try to account for everything, but as we talked about early on, the real world is messy. It's why Galaxy batteries caught on fire and exploded. Again, we want to get ahead of manufacturing hangups early. So we asked some questions. Have you mapped out your complete supply chain? Where do our supplier risks lie? What type of tests do we need to perform on production samples for safety, for durability, for quality control? Have we determined and communicated our tolerances, finish and packaging requirements? Like, are we polished on all of these pieces? We're ready to move on when we've received some really solid feedback. We've hopefully had a couple aha moments, and we're ready for the real deal. All right, so this is step 9. There's only one step left after this. Now we're ready for the go-to-market manufacturing run. The context here is we're about to pull the trigger in a big way. Your software has ideally been good for a while now. If you do this right, there's no scary like scale up phase, right? The infrastructure is tested, everything is ready. There's no drama with the software. And we really want to start focusing on economies of scale and how we can optimize for that. Cost optimizations, component negotiations, making sure that you've got an A team that you're working with your manufacturing partner, wherever they are in the world. And additionally, you want to nail down details like personnel and schedule for quality checks on the production units. You want to nail down, the internal organizational requirements for providing customer support and customer success. You're ready to move on when you don't have a heart attack thinking about 1 million units. All right, last up, emulation with digital twin. And the goal here is to imitate appearance and behavior of a physical object or system. All right, so how it works is that you have a device out in the world that uses sensors. It's connecting to a cloud-based system. That system receives and is processing all the data against business and contextual data. Using all this information, you can then build a digital twin, a digital model of how your device is performing or how it's supposed to be performing in the real world, except for now, you can start to account for real world conditions. At this point, this is where you would start to think about predicting and diagnosing failure. You want to better understand defects that are happening that you weren't planning on. You're starting to dispatch preventative maintenance. The reality is that every project that we work on is under timeline and budget pressure. And under that pressure, decisions have to be made, right? You're buying an expensive component off the shelf because you didn't have time to build a custom one yourself. You might have to be adding more material than necessary because you didn't have time to run all the calculations on breaking points. But now you have the opportunity to gather real data from the field and incorporate that in building your next version. And you hopefully then have a better grasp on how to make improvements and kind of those data-driven decisions. So you're ready to move on when you start eyeing step 1 again. And the circle of life continues. So to wrap up, one of our software engineering practice leads, Daniel Spofford, says, nothing beats the real world. The real world is messy. That's why Agile IoT is relevant and necessary. And a couple closing thoughts are, it might feel daunting to like ditch Waterfall to try to convince some executive stakeholders that, this should be the right approach, but this is a well-vetted path. We, over the course of hundreds of implementations and product launches, this is what we've found that works. And other companies, I think, say the same things. There's playbooks, there's manuals, there's tons of documentation and research. It's a well-vetted path. Second is the key to making it all work is communication and cadence. At the end of the day, that's it, right? It's like, can groups communicate effectively, and can you stick to a cadence that is, 1 to 2 week sprints, and not get like lost or not get, stuck in going down a rabbit hole somewhere. And lastly, Agile IoT is a journey of 1,000 tiny steps. There's no one big step. There's no one day that changes everything. It's just a lot of little steps, and you hopefully get everybody on the same page. And with that in mind, turn it back to Ken for questions.
All right. So I think that we've gotten a ton of questions in, and folks out there listening, make sure that you keep sending them in, because we have some time here. So we're going to be able to get into some of these questions. And I want to hit you first. I've got a ton, but I want to hit you first with how long does it usually take to launch? What are some of the factors that can change that timeline? I mean, if you're trying to switch over from Waterfall, how much shorter is your time to market?
Great question. Every project is different, right? Disclaimers. With that in mind, though, we can typically start from an idea and actually get a physical product launched in 6 to 8 months, say, kind of in that sweet spot. The important thing is it's not years, and it's also not 2 or 3 months. That's crazy. That's irresponsible. And so it's typically in that range. What are some of the factors? Availability of our clients in the team, right? We have daily stand-ups as a part of our process. That's a daily touch point with our stakeholders. And I would say, you have a lot of different inputs that you need to organize. So having like a really strong project manager or product manager is critical. Having the buy-in from the client or the executive stakeholders, having budget to make some decisions, to purchase equipment necessary, to not be penny wise and pound foolish. So like as a company, we put Volterra printers on all of our mechanical and electrical engineers' desks so that they can actually print 3D print. They can print boards on their desk and not have to wait for those turnaround times, like from somebody, some shop that's printing a board and shipping it to them. That's a $5,000 machine. These are like, Agile is not cheap, right? Agile is not inexpensive. So just kind of getting everybody on the same page, bought in, I think are kind of the key pieces here.
I mean, what's that old equation? You can, there's fast, there's cheap, and there's good, and you can pick two.
Yep. Yep.
So I want to jump into sort of all of this. The Agile process makes a lot of sense to me, and I get it, but why is it ideally suited to IoT development? Why should IoT companies be looking at this specifically?
Yeah, great question. It's you can get away with bad habits if you are just working on a single silo of software, of mobile application development. Like you can frame out and finalize the design on a mobile application and then go develop it with some small changes. IoT lends itself to being a lot more risky because of how many different disciplines need to pull together. You need to have hardware engineers that need to be fully aware of the software implications. You need to have electrical engineers that need to be in touch with, other facets of this. And, like there are just so many moving pieces that the synchronization between those pieces, if you want to launch anything without a multi-year time horizon, it just doesn't lend itself to Waterfall. It lends itself to Agile.
Sure. I know I promised you a couple of hard questions, so let's hit with one now. When you're talking about step 7 and step 8, those are basically your step out of pilot phases.
Bingo. Yeah.
And what stops you from getting stuck there? Just like with the waterfall process, and being in a position where, oh man, that first 100 run didn't work right. We got to go all the way back and we got to look at everything. And now you're in that same kind of cycle.
Great question. And sometimes you don't want to get stuck in step 7. You want to get stuck in step 6. if you're gonna have to kind of cycle through one of the steps a couple times, it's step 6 where we have the microfactoring run. By the time you're pulling the trigger on doing 100, you really want to have this pretty well baked. You want to have like a lot of your assumptions validated, and you can do that cheaply and inexpensively in the microfactoring run. And so, not every project goes off without a hitch, right? And like you oftentimes, hit different stress points in the project, but by taking things in like such a broken down iterative manner, you're never trying to boil the ocean, right? You're just like taking a couple little steps forward. And by the time you do that 100-piece run, like you're feeling pretty good. And we don't find a lot of issues going from the 100 to 1,000 to larger. At that point, things move pretty seamlessly.
All right. So we've gotten a bunch of questions in about design specifically. We've got one question here about incorporating design thinking into Agile IoT development. Another in spending time in the design stage and iterations rather than developing super fast to get it out to consumers. My sort of design angled question is, how much of this can be done through digital twin? Because it feels like you can do a lot of this if you've got good data sets available to you. A lot of the process before manufacturing,
big time,
just in virtual land, especially if you're developing software rather than hardware. Hardware might be a little harder because you can't. It's a lot harder to model that, I think. So I'm curious if you could just talk a little bit about design and what some of the things you've got to think about that are different about Agile and IoT.
Yeah, great question. And in terms of design thinking, before we launch into this, our design practice lead, Steve Beltkamp, published a blog post on our site on calm design. And this is, I think, a really important thing when we start to talk about devices and design in general. And that's that I think one of the important things that we really embrace is like creating a frictionless user experience and creating not technology that overstimulates, that is intended like to capture eyeballs and keep them. One of the classic metrics is like, engagement, like how much stickiness of eyeballs do you have? I would like, and we would like to think about this a little bit differently, which is that technology should add to kind of peace of mind, should be, human, and should frankly get out of the way as much as possible. So anyways, from a design thinking and like human-centered design perspective, those are principles that we like actively try to bring to all of our projects. How does that relate to Agile? You can do an enormous amount, like you said, in digital twin. One of the other things is that when we want to test software, for example, we can test things like when that software is interacting, by doing things like turning on a light, like success equals a green light. Or so like we're abstracting the software from the hardware. And, when we're talking about like, if somebody, we're building a system that uses facial recognition when people are walking through, a door, like we don't need to yet integrate with the mechanical turnstile yet. Like we don't need to integrate with the physical, like we'll just turn on a green light if success happens in the virtual space. So you can abstract it that way. You can also abstract it the other way, right? Which is you can start to build prototypes and physical pieces of this system to start to test the kind of human factors without it being a perfect system yet. So I'll leave it there.
Yeah, we're getting so close to the end of our time here, and we've gotten a ton of good questions in. I want to force you to be fast here so we don't run over time, but I really want to hear you talk about step 11. One of our questions that came in here wants to know, what is step 11? What does your customer ongoing support look like? Does that send you back into the process sometimes? you can find sources of project failure there in that 11 plus. And I'd love to hear you talk about that a little bit.
Big time. All right. So, as a company, we do provide ongoing support and aftercare and hypercare and different packages. We support the devices that we launch out in the field. It's critical. The thing that I'll say where failure happens is this. When we look at a long-term time horizon for a project, a great product manager is keeping three things in balance. That is new features, that is cleaning up technical debt, and that is running experiments to validate the new features before you build them. Yeah. And one of the things that we encounter all the time is like we launch something and customer, client, whatever is saying, okay, next round of features, let's try to jam them in, and the obsessive focus is on new features always. And what we do as tech partners is we come in and we say, okay, look, yes, new features are going to happen, but these three things need to be in balance. And so a big focus is going to be on technical debt, cleaning up technical debt. You always accrue technical debt. So 1/3 of the time when we look at a calendar year, technical debt. The next step is going to be running experiments to validate new features, fake door tests, all kinds of tests that you can do to validate. And then that third slice of the pie is going to be actually building those new features. And so, and you can chop it up. It doesn't need to be like step 1, step 2, step 3, right? You're constantly like adjusting where those investments are being made. But that approach to ongoing product development has been a really important framework that we look back on from like a high level perspective to ensure that things go well.
Sure. And that wrapped us up beautifully, well timed. Thank you so much to Ben Wald for this amazing walkthrough of this process. Really appreciate that. Folks out there listening, thank you for all your questions and all your participation. If you have more questions, feel free to reach out and we'll try to get you all the answers we can. If you want to refer back to this presentation, as I'm sure you will, it'll be available in an archive on iotforall.com, and you'll receive some email communication on how to access that. Finally, I have been Ken Briodagh, Editorial Director for IoT for All, and your host, and I'd like to thank you all for joining us today. And once again, to thank you, Ben, for walking us through here. Really appreciate it.
Thank you, Ken. Appreciate it.
Thanks a lot, everyone. This has been a walkthrough on Agile IoT with Very, and we appreciate you all joining us. Have a great day.